Ladies and gentlemen, welcome back to 5 Minutes of Math. This is Mr. Lunsford, and I'm glad you joined me this evening. Tonight's homework is for the evening of May 2nd, 2018, and our topic tonight is our SOL Review Part 6. Let's get started. Alright, so our first question here, and I'm paraphrasing, what is the probability that he chose and ate a chocolate chip cookie first and a peanut butter cookie second with no replacements? Because if you're eating cookies, you're not putting them back. So this is all probability, and these events are going to be dependent, because when you pull an object out of a collection and then choose again, your second choice is going to depend on your first choice, and you'll see why in a minute. Alright, so we have total items here. We have 8 oatmeal and raisin cookies, 15 sugar cookies, 12 chocolate chip cookies, and 15 peanut butter cookies. And if we add all of those up, we have 50 items. And with this type of question, the first thing you want to do is find your totals. Now, event number 1 is where you eat that chocolate chip cookie. There's 12 chocolate chip cookies available and 50 total, so that's 12 out of 50, or 0.24. If you're using decimals, it's 0.24. If you're using fractions, it's 12 out of 50, and I'll show you both ways. All right, our second event, though, is where we eat a peanut butter cookie. And we have 15 peanut butter cookies, and that's 15 out of 49 total cookies. Because you ate one in the first event, no matter which cookie you picked, there's going to be one missing. So there's 49 available cookies, and there's 15 peanut butter cookies. So if you multiply those two together, and yes, that decimal down there, 0.306122, is 15 divided by 49. Multiplying those two together, you get 180 divided by 2,450, or 180 over 2450. As a decimal, that's 0.0735. Since the answers are given in the form of fractions, then what that means is we have to take our number as a fraction and simplify it. 18 divided by 2,450, the easiest thing to do is divide by 10. Thankfully, the question does the same thing, and we have 18 over 245. The answer is B. The answer is B. All right, moving on to number 2. Number 2 says if 67.6% of all eligible voters voted, what is the chance that 2 randomly selected eligible voters all voted? So, if you're looking at the pool of all the voters, and these are just the people who are eligible to vote, and 67.6% are polled, we are not going to hold the people hostage who actually answer the poll. So this event is actually going to be an independent event. Now, I've also put up here how to convert a percentage to a decimal, and you divide by 100. Now, that's going to come into play when we actually calculate our probabilities. So let's take a look at that. We have 67.6 divided by 100, and that's 0.676, times 67.6 divided by 100, that's 0.676. Again, these people doing the poll could have chosen the same person. They could have also chosen a different person, but either way, you're putting that person back. So when you release that person from the poll, they're going to go vote and go on about the rest of their day. So that's why these are independent events. We're calculating these probabilities. If we multiply them together, we get 4,569.8 over 10,000, or 0.457. Now, since the answers are given in percentages, this time we need a decimal. So 0.457 times 100 is 45.7%. And that's why this answer is H. This answer is H. All right, going on to the next part. We have 2 spinners, and if each spinner is spun one time, what's the probability of spinning a prime number and a vowel? So here's our 2 spinners, and anytime you have a spinner or you're working with dice, you're having independent events happen. And event 1 says, let's spin a vowel. There's one vowel here, A, in math, and yes, they use M-A-T-H. The second event, 1 out of 4. There's one vowel there and 4 choices, so that's 1 out of 4, or 0.25. Event 2 looks for prime numbers. That's just 2, 3, and 5. All right, so that's 3 choices out of 5 possibilities, and that's 0.6. Now, if you multiply those together, what you end up with is 3 out of 20, or 0.15, 15 hundredths. The answer is A. The answer for this one is A. Moving on. This is number 4. Rebecca rolls a number cube 3 times. And by the way, a number cube looks like this. If there's 2 of them, we call them dice. What is the probability that she rolls the same number all 3 times? Well, this is a set of independent events because you're not going to rip whatever number you pick, you can't rip it off the die when you finish rolling it. So each time you roll, it's going to have the same number of choices available. So that's why it's independent. Here's event number 1. Let's say we pick the number, I don't know, 3. There's a 1 out of 6 chance of rolling a 3 the first time. That's 0.167. The second time we roll that die, it's going to be 1 out of 6, trying to roll that 3. And the third time we roll it is also 1 out of 6. And if we multiply all this together, we get 1 over 216, or 0.0046. Thankfully, the problem gives the answers in fractions, so the answer is J. The answer is J. All right, moving on. What is the probability that Angela will get 2 hits in her next 2 chances to bat if her batting average is 0.35? That means that every time she goes up to bat, let's say she's playing baseball or softball or something, she's got a 35% chance of hitting the ball. Now, since these 2 events are independent of each other, we'll treat them that way, as independent events. Event number 1 is 35 over 100, 0.35. The second event is also 0.35. And because she might strike out the first time, but she might hit the second, and vice versa. She might hit a home run the first time and strike out the second time. So we multiply these together. We end up with 1,225 over 10,000, or 0.1225. The answer here is A. The answer is A. All right, that's it. Y'all take care, and remember, math is not just about numbers. It's all about the relationships that surround us every day. Have a good one.